Hey, Trig kids, today we're looking at section 6.4, sum and difference rules for sine and tangent. Last video looked at cosine, this time sine and tangent on trig with Mr. Forbes. Notes out, and away we go. A lot of what we're going to do in this video is very similar to the last video. We're just going to have different identities for sum and difference of sine and tangent. So sum and different identities for sine. Since sine of theta is equal to cosine of 90 minus theta, we're going to let theta is equal to a plus b. Therefore, sine of a plus b has to equal to its cofunction, cosine of 90 minus quantity a plus b, which is cosine of 90 minus a minus b. Therefore, we can split this up to get, here's our first angle, minus b is our second angle. So this is cosine of 90 minus a times cosine of b plus sine of 90 minus a times sine of b. And that gives us our formula. The cosine of 90 minus a, well, that's just the cofunction for sine. So that's sine of a cosine of b plus sine of 90 minus a, well, that's cosine of b sine of a. So the sine of a plus b is the sine of a cosine of b plus cosine of a sine of b. And the sine of a minus b is going to be the same but the opposite sign. So that's sine of a cosine of b minus cosine of a sine of b. Sum and difference for tangent. I'm not going to prove these to you. I'm just going to give them to you. So tangent of a plus b is tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. And just like the others, we're going to switch signs for tangent of a minus b. That's going to be tangent of a minus tangent of b over 1 plus tangent a tangent b. All right, so here we go. Example 1. Find the exact value of each expression. So let's find the sine of 15. So we need a way to come up with 15. Well, our smallest angles that will give us 15 is going to be sine of 45 minus 30. Again, there's a lot of bigger angles you could use, but we're going to use those because they're small and nice and easy to work with. And so that's going to get us our function, our identity, sine of a cosine of b minus cosine a sine of b. And so we're going to plug into that identity and see what we get. Using 45 for a and 30 for b, we're going to get sine of 45 times cosine of 30. Note this is not cosine of negative 30. The negative is with the identity. Okay, so we're going to leave that negative there. So this is cosine of positive 30 minus cosine of 45 times sine of 30. And again, that's going to be a positive 30. The negative goes with the rule, not the number. It goes with the identity, not the number. Now we're back to our trig vitamins. And so sine of 45 we know is root 2 over 2. Cosine of 30 is root 3 over 2. Minus cosine of 45 is root 2 over 2. Sine of 30 is 1/2. That's going to give us root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 all over 4. So there is the exact value for the sine of 15. Letter B, tangent of 13 pi 12ths. So we need a way to get 13 pi 12ths. So we're going to recognize that 13 pi 12ths is 9 plus 4. So 9 pi 12ths plus 4 pi 12ths. So this is tangent of 9 pi 12ths plus 4 pi 12ths. Why did I pick 9 and 4. Well, that gives us the tangent. 9 pi fourths becomes 2 pi thirds. No, it doesn't. Yes, it does. Both divide by 3, giving us, sorry, not 2 pi thirds, 3 pi fourths plus, here both divide by 4, leaving us with pi thirds. There we go. So 3 pi fourths plus pi thirds, which would be, if you want to do this in degrees, would be tangent of 135 plus 60. All right, so, or you could have changed 13 pi 12ths into 195 if you wanted to start with, and then just be in degrees the whole time. So we're going to use our formula for the sum of tangent. And I'm going to try and sneak that on here. So tangent of A plus tangent of B over 1 minus tangent A times tangent B. So that gives us, I'm going to do this in degrees. So that gives us tangent of 135 plus tangent of 60 all over 1 minus tangent 135 times tangent of 60. So what is the tangent of 135? That's a 45 reference angle. So tangent of 45 is 1. Second quadrant is negative. So that's a -1 plus tangent of 60 is the big one. That's a √3 all over 1 minus tangent of 135. We already did that. That's a -1 times tangent of 60. That's a √3. Those negatives cancel. So we get a -1 plus √3 over a 1 plus √3. Those are not the same, so we can't cancel, but we know we can get the radical out of the denominator by multiplying by the conjugate. So we're going to take our -1 plus √3 over 1 plus √3 and multiply by the conjugate, 1 minus √3. And we're doing this straight from college algebra. We're going to FOIL the denominator. So 1 times 1 is 1. That gives us a minus √3 plus √3 plus, sorry, not plus, minus. √3 times √3 is √9, which is a 3. Notice the middle two cancel, and that has to always happen when we do multiply by the conjugate. In the numerator, a -1 times 1 is -1. That gives us a plus √3. 1 times √3 is plus √3, and then a minus √9, which turns into a -3. We're going to simplify. 1 minus 3 is -2. In the numerator, -1 minus 3 is -4. And then plus √3, there's 2 of them, so that's 2 √3. And then finally, we can simplify. Notice -2 will actually divide into both of these, leaving us with 2 minus √3 as our final exact answer. Lots of algebra manipulation going on in there. Remember, we don't want to leave roots in the denominator. We want to rationalize. Here we rationalize by multiplying by the conjugate. Letter C. We can also go backwards. So note, this is a bunch of tangents, and that actually matches our difference of tangent formula. This is the tangent of A. So A has to be 100 minus tangent of B, so B is 70, over 1 plus tangent of A, tangent of B. And therefore, that's got to be, let me rewrite that. So this is tangent of A. So A is 100 minus tangent of B. So B is 70 over 1 plus tangent of A times tangent of B. Therefore, we verified that matches the identity. And therefore, this has to be tangent of A minus B. Well, that's tangent of 100 minus 70, which is tangent of 30, which is √3 over 3. So we can go backwards as well, just like we did with cosine from the last lesson. Example 2, write each function as an expression involving functions of theta. So we want sine of theta minus 270 to be an expression involving just theta. So we want to get rid of the 270. Again, to do that, we're going to use our trig functions, trig identity. So this is the difference of sine. So sine of theta minus 270 is, remember, sine of A cosine of B minus cosine of A sine of B. So this is A, this is B. So this is sine of theta times cosine of 270. Remember, it's a positive 270, not a negative. The negative goes with the identity, not the number, minus cosine of theta times sine of 270. And then we're going to evaluate. Sine of theta is still sine of theta. Cosine of 270 is, so that's our down from the origin. Cosine is adjacent over hypotenuse. That's a 0 over 1. So cosine of 270 is 0, which knocks that out, minus cosine of theta. Sine of 270 is vertical. That's going straight down. So this is a negative 1. That went to 0. Negative times negative cancels, leaving us with cosine of theta. Do the same thing with tangent. We've already looked at that identity. So we're going to recognize that this is A, this is B. And so we're going to plug into our identity. This is tangent then of theta, plus tangent B is tangent of 3 pi over 1 minus tangent of theta times tangent of 3 pi. And we're going to check 3 pi real quick, tangent of 3 pi real quick. We can do this on our calculator, and we find out that that's actually equal to 0. That's going to help us out a bunch. So this is tangent of theta plus 0 over 1 minus tangent of theta times 0. Well, that goes to 0, that goes to 0. So we're just left with tangent theta over 1, which is just tangent of theta. Same thing for sine of 120 plus theta. We're going to use our identity for sum of sine, and that is the sine of A cosine of B keeps the same sign plus sine of B, well, cosine of B sine of A. And we're going to plug in. So this is 120 is A, theta is B. So this is sine of 120 times cosine of theta plus cosine of theta I got those backwards, cosine of A, sine of B. So cosine of 120 times sine of theta. There we go. Simplify, sine of 120, reference angle in the second quadrant is 60. Sine of 60 is root 3 over 2, that's positive, times cosine of theta. Cosine of 120 is, again, reference angle 60. Cosine of 60 is 1/2. Second quadrant, though, that's a negative 1/2 times sine of theta. We've simplified as much as possible, so that's our answer. Example 3 looks at another version of a problem. Suppose that A and B are angles in standard position with cosine of A equals negative 7/25. We know A is between pi and 3 pi halves, so it's between 180 and 270, so it's got to be in the third quadrant. And B is negative 3/5, and we know that B is between 3 pi halves and 2 pi, so B has to be in the fourth quadrant. We want to find sine of A, cosine of B, sine of A, tangent of B using identities. All right, so what do we have already? Well, we already have cosine of A. We already have sine of B. So we want to find their reverses. We can do that easily using Pythagorean identities. So let's go ahead and start with A. So we know sine squared of A plus cosine squared of B, A, is equal to 1. That has to be the same angle. And we know cosine of A is negative 7/25. So that gives us sine squared of A plus negative 7/25 squared equal to 1. That gives us sine squared of A plus 49 over 625 is equal to 1. We can solve then for sine squared of A. 1 minus 49 over 625 is 576 over 625. Square root both sides. Therefore, sine of A has to be 24/25. We know that's a plus minus from the square root. Now we need to figure out which sign it is, plus or minus. Well, we're going to recall that angle A is in the third quadrant because it's between pi and 3 pi halves, 180 and 270. And we know cosine in the third quadrant has to be negative. So this has to be a negative 24/25. Now let's look at our B. We already know sine of B, we want to find cosine. So we're going to look at sine squared B plus cosine squared B is equal to 1. We already know sine is negative 3/5. So negative 3/5 squared plus cosine squared B is equal to 1. Negative 3/5 squared is 9/25 plus cosine squared B is equal to 1. Cosine squared B then is equal to 16/25. We'll square root both sides. Therefore, cosine of B is equal to plus or minus 4/5. Again, now we need to go back and evaluate, is that a plus or a minus? B is in the fourth quadrant. Cosine's only positive in the first and fourth quadrant, so this is in fact a positive 4/5. So there's our cosine B, there's our sine of A. Note we already had cosine of A from our problem, which is negative 7/25. We already had a sine of B from our problem, which was negative 3/5. We're going to use those then to find our final two parts, tangent of A and tangent of B. Therefore, tangent of A has to be sine of A over cosine of A. Sine of A we just calculated is negative 24/25 divided by cosine of A, which is negative 7/25. We're going to flip that sucker and multiply, which is negative 24/25 times 25 over negative 7. 25s cancel, the negatives cancel. We get 24/7, which is tangent of A. We're going to do the same thing for B. So tangent of B is sine of B over cosine of B. Sine of B is negative 3/5. Cosine of B is 4/5. We're going to flip that sucker and multiply as negative 3/5 times 5/4. The 5's cancel. Therefore, tangent of B is negative 3/4. Long problem, lots of information. Slow and steady wins the race. Next part, find each of the following. Using the same information, we're still on the same problem, so keep that open to you if you got it, able to see that stuff. So we're still doing the same problem. We want to find sine of A minus B. Well, sine of A minus B is our identity, and that is sine of A cosine of B minus cosine of A sine of B. Well, we know all of those from our last slide, and so we can plug all that in. Sine of A is negative 4/25. Cosine of B is 4/5 minus a negative 7/25 times a negative 3/5. Those two negatives cancel. We can work that out on our calculator. That gives us a negative 96 over 125 minus 21 over 125, which is a negative 117 over 125 as our answer. Can we check to make sure that that's true? We know angle A was in the third quadrant, angle B was in the fourth quadrant. So if we do a third quadrant minus a fourth quadrant, we'll come back to that in a second because that's actually our part C. Part B then, we want to find tangent of A minus B. Again, using our identity, that is tangent of A minus tangent of B over 1 plus tangent of A times tangent of B. Again, we have all those values. That was from our last slide. So we're just going to plug in all of those numbers. This is 24/7 minus a negative 3/4 all over 1 plus 24/7 times negative 3/4. Remember to use parentheses around all of this if you do all of that at once on your calculator. What you should get there is, if you do this separately, is 96 plus 21 over 28 if you use crisscross smiley face, and 1 minus 72 over 28, which gives you 117 over 28 all over negative 44 over 28. The 28's cancel. And so we get 117 over 28, which is sorry, 117 over 44, negative 44. Therefore, our answer is negative 117 over 44. Part C, then we want the quadrant of A minus B. How are we going to do that? Well, let's look at our quadrants in terms of where we ended up in terms of sine and tangent. So we ended up with sine being negative. So we got sine of A minus B is equal to a negative value. We know that all students take calculus. So where is sine negative? Well, sine's not negative in the first quadrant, can't be there. Sine is not negative in the second quadrant, it can't be there. So that leaves us with the third and fourth quadrant. And then we're going to look at tangent of A minus B. Well, tangent of A minus B is also negative. Well, tangent of, in the third quadrant, is positive, so it can't be there. Therefore, we must be in the fourth quadrant where both sine was negative and tangent was negative. So we must be in the fourth quadrant. Example 4, we can also verify that an equation is an identity. So we want to verify that tangent of pi force plus t plus tangent of pi force minus t is equal to 2 secant squared t over 1 minus tangent squared of t. All right, we're going to start this by recalling our tangent sum and difference formula. So tangent of pi force plus 1 is tangent of pi force plus tangent of t all over 1 minus tangent of pi force times tangent of t. And we're going to get lucky because tangent of pi force, well, that's just 1. So we have 1 plus tangent of t over 1 minus tangent of t. On the right-hand side, tangent of pi force minus t, that is tangent of pi force minus tangent of t all over 1 plus tangent of pi force times tangent of t. Again, we're going to luck out because tangent of pi force is just 1. And so we can rewrite this as 1 minus tangent of t over 1. Tangent of pi force again is 1. So this is just 1 plus tangent of t. That looks like a pi. That's supposed to be just a tangent of t. All right, now what do we got? Well, now we have these two added together. So we're going back to this. We got those two, we're going to add them together. So that's our kind of starting information. So now we have 1 plus tangent of t over 1 minus tangent of t plus 1 minus tangent of t over 1 plus tangent of t. We want to get back to one term. How do we know we want to get back to one term? We're trying to get to something that looks like this. And you might see it from here. If we multiply these denominators together, we're going to get a difference of 2 squares. That's going to be that denominator. So we're going to do crisscross smiley face. And that's going to give us 1 plus tangent of t times 1 plus tangent of t is 1 plus tangent of t squared, plus 1 minus tangent of t times 1 minus tangent of t is 1 minus tangent of t squared, all over 1 minus tangent of t, that's our smiley face, times 1 plus tangent of t. And let's see what we get when we simplify that. So in the numerator, we're going to square this one. 1 times 1 is 1. 1 times tangent is tangent t. There's going to be 2 of those. So 2 tangent of t plus tangent of t squared, plus 1 times 1 is 1. There's going to be minus 2 tangent of t, and then negative tangent t times negative tangent t is plus tangent squared of t. The negatives cancel when we multiply that one out. In the denominator, when we FOIL, we're going to get 1 times 1 is 1. 1 times positive tangent of t is tangent of t. 1 times negative is minus tangent of t, minus tangent squared of t. And what happens? Well, tangent t's cancel in the denominator. In the numerator, a plus 2 tangent t cancels with a minus 2 tangent of t. And what's left? In the numerator, 1 plus 1 is 2. And we're left with 2 tangent squared of t's. In the denominator, we're left with then 1 minus tangent squared of t. Now let's go back with our original problem and check where we're at. Well, we got the 1 minus tangent squared of t. Now we want the top to look like a 2 secant squared of t. Well, this looks like a Pythagorean identity. The 2 must come from factoring. So let's factor out a 2 to leave us with 1 plus tangent squared of t over 1 minus tangent squared of t. And we're going to check with our Pythagorean identity. 1 plus tangent squared of t is in fact secant squared. So 2 secant squared of t all over 1 minus tangent squared of t. And we got it to look the same, therefore we're good. Homework for section 5.4, we're going to do page 229. We're doing problems 1 through 6, 10 through 46, 54 through 66 evens. Have a good day, Maroons.